Hello viewers, welcome to T-Ben Math class. In today's lesson, we're going to look at how to find the magnitude or length of a vector. The length, the magnitude or distance. So we have if vector AB is equal to xy or xi plus yj. This is in the column form and this is in the ij form, in other words, in the Cartesian form. Then the magnitude of AB denoted by, so the moment you see this, it means that you are finding the magnitude. At times, the word magnitude will not be spelled, but you see this in the question. The moment you see it, it means that you are finding the magnitude, the absolute form. It means that you are finding the magnitude. So it is giving us vector AB, its magnitude is equal to, in a square root, x squared plus y squared. So when you pick the x component, you square it. When you pick the y component, you square it. Someone may ask that why is it that when it is in this form, we don't square xi all squared? We do so. But when you have this, it will be x squared I dot I. It will not be I squared. And I dot I in vectors is equal to 1. So multiplying 1 by x squared will be the same x squared. The same thing. J dot j is 1. So when you see it, it means you multiply 1 by the y squared. That's why we have x squared plus y squared. That is the implication. Let's consider our first example. In our first example, we have given that the vector AB is equal to -5, 12. Find the magnitude of vector AB. So let's look at how this will be found. In the definition for magnitudes of vectors, we saw that to find the magnitude of a vector, it is always denoted by this, the absolute form, that is the magnitude. And it was said that this will be equal to the square root of x squared plus y squared. So what is the vector? The vector AB was given as -5, 12. In this case, our x is the -5 and our y is 12. So our magnitude will be equal to, in a square root, the -5 will be squared plus 12 squared. What you do here is that when you are punching this one on your calculator, make sure you put the -5 in a bracket. Some students will put it or will just punch it without putting it in a bracket. When you do that, the square will not affect the negative sign. So what you do is that put everything in a bracket before you square. So squaring -5 will be 25. And then when you square 12, you will get 144. So this will give us 25 plus 144 will be 169. It means that you find the square root of 169 and that will give you 13 units. The units should always be brought because every distance has to be measured in a certain unit. In our example 2, we have given that the vector CD is equal to 8, 15. Find the magnitude of vector CD. So let's quickly look at how to find the magnitude. We have the vector given as 8, 15. And we know from the definition that when you want to find the magnitude, we write this. The magnitude is equal to the square root of x squared plus y squared. So by substitution, we're going to put 8 in place of x because in a vector we have x as 8, we have y as 15. So we will have 8 as 8 squared plus 15 squared. When you square 8, it will give you 64. When you square 15, you will get 225. By addition, we will have 289. When you add the 2, you have 289. And the square root of 289 is 17. So the answer will be 17 units. So this will be the magnitude of vector CD. Our third example has this information. If vector xy is equal to negative 5i plus 10j, find the magnitude of vector xy. So quickly, we have xy to be negative 5i plus 10j. So to find the magnitude, I said in the definition that at times you don't see the word magnitude, but you see the absolute form of the vector. It means that we are finding the magnitude, the distance, or the length of the vector. So let's look at how to go about this. The formula says in a square root, add the square of x and the square of y. So looking at this, we know that when you see the I component, it represents the x component, and the j component also represents the y component. So by substitution, we're going to have negative 5 squared plus 10 squared. So we will square our negative 5. So doing that will be 1. So you get 25. Then when you square 10, you will get 100. At this point, adding them will be 125. And then if you want to leave it in a radical form or in a set form, then this will be 5 root 5 units. 5 root 5 units. You can also leave it in a decimal form, but you want to leave it in the radical form. Our fourth example is if vector PQ is equal to AI minus 12J, and the magnitude of vector PQ has been given as 15 units. Find the value of A. So looking at this, we have been given the vector, and then we also have the magnitude. And in a vector, the x component, the value there was not given. So it has been represented by A, and we are being asked to find the value of A. So let's quickly look at how to do it. So our vector PQ is known as AI minus 12J, and the magnitude of the vector has also been given as 15 units. We can do this by using the formula for finding the magnitude of a vector, and it goes like this. The magnitude of vector PQ will be the square root of x squared plus y squared. We have been given the magnitude in the question. The magnitude is 15. So we will write 15 is equal to the square root of, now the x component is A. So it will be A squared. Then the y component is negative 12. So negative 12 squared. So we will square each of the parts in the square root. So it will be 15 is equal to, now when you square A, you get A squared. When you square negative 12, it will be 144. Now in order for us to find A, the expression at the right hand side has been engulfed by a square root, or has been covered by a square root. In this case, we need to get rid of the square root, and we do so by squaring both sides. So you square here, then you square here as well. The square will take care of the square root here, and squaring 15 will be 225, and this will be equal to A squared plus 144. So by extension, we're going to have grouping of like terms because this and that are like terms. So we will bring the 144 to where the 225 is. So we will have 225 minus 144 equal to a squared. Now when we have to find the difference, 225 minus 144 will be 81 equal to a squared. So in order to find a, we will get rid of the square, and we do so by finding the square roots on both sides. So square root here, square root there. So the square cancels the square root, and the square root of 81 is 9. Therefore, my a is equal to 9. That will be the value of a. Before we bring today's lesson to an end, I would like to give you prior questions. And the questions are two. Question 1, question 2. Solve the two questions, put the solutions at the comment section. We will meet another time for another video. Now, before I go, if you really found this video useful, subscribe to my channel and like the video. Until then, goodbye.